The next rule that we're going to talk about in this section is our product rule for exponents. So as we're thinking about this product rule, for any non-zero base, x to the a times x to the b equals x to the a plus b. Right? So if we have either a number or variable, right, as the same base, what we're going to do is we're actually going to add the exponents. We're not going to change the base. And if we look at what this means, I've got a couple of examples written out here. Right? So if we think about 3 squared, 3 squared means 3 times 3. Right? Then if we multiply that 3 squared times 3 cubed, well, 3 cubed means 3 times 3 times 3. Right? And if we add our exponents, our 2 plus 3 gives us 5. So we get a final answer of 3 to the 5th power. Similarly, the same thing holds for variables. Right? So our base could be a number or variable. Right? So for example, x cubed is x times x times x. X to the 4th means we have 4 factors of x. X times x times x times x. We put these together, well, we have a total of 7 factors of x, or x to the 7th. So as we're going through these problems, as long as we have the same base, right, we can multiply our expressions, and we can simplify them by simply adding our exponents. Right, so for example 4, right, x cubed times x to the 6th. Well, we're going to add our exponents. 6 plus 3 gives us 9. Right, 2 to the 4th times 2 to the 4th. Our base stays 2. We're not doing anything with that 2. We're keeping that number. Right? And then we're just adding our exponents. 4 plus 4 gives us 8. Right? K times k to the 4th. Right? So this is one case where we may want to add in an invisible 1 for our exponent. Right? So if we added in an invisible 1 there for our k, right, then we're going to simply add 1 plus 4 to give us 5. Right? So we're using our first power rule that we already talked about, and sometimes it may be to our benefit to write in our exponents. Whether or not you physically write them in is totally up to you. You can just think about them as having exponents of imaginary 1. Same thing is going to be true with example D. Notice that we have q times q. Well, both of those also have an invisible 1, right, as their power. Right? So then if we add up 1 plus 1, we get 2. Right? So q times q gives us q squared. Right? And thinking about our definition, if we were to go the other way, right, we would say that q squared means 2 factors of q, which we have here. We have 2 factors that are q. Right? For E, we have y to the 0 times y to the 6th. Remember from our last example in our 0 power rule, anything to the 0 power is equal to 1. So this really means we have 1 times y to the 6th, and 1 times y to the 6th is just y to the 6th. Right? Again, write out that middle step using that 1 if you want to. If you want to jump right to the answer, that's also fine as well. Right, then for our last example using this product rule, x cubed times y to the 5th. Well, if we look at this example, unlike examples A through E, notice that we have 2 different bases. We have an x and a y. That means we cannot combine these bases. Right? So we're going to leave our answer here as x cubed times y to the 5th. We cannot combine our exponents using our product rule because our bases are not the same. Right? So our product rule again for any non-zero base, again base has to be the same. Right? X to the a times x to the b gives us x to the sum of a and b, or a plus b power. We're going to use this a lot in a section later on when we're working through and doing multiplication of our polynomials that we're going to start talking about in the next section.